Es especialista en recuperación de especies endémicas en peligro crítico y ha estado involucrada en conservación de varias especies endémicas en la isla de Mauricio, Hawái y más recientemente en el Cabildo, Insulares. Tiene experiencia en el manejo de especies amenazadas y en la erradicación de vertebrados invasores. Trabaja con instituciones locales, internacionales y gubernamentales que operan en la región del Caribe para promover, desarrollar e implementar planes de recuperación, programas de recuperación de especies en peligro de extinción y su conservación. El proyecto de recuperación de la Paloma de Mauricio, la historia del proyecto, problemas encontrados y situación actual en la ponencia.
Gracias. Well, I'm afraid I'm not going to follow the last presentation and speak in Spanish. My Spanish is too terrible for you, so I'm afraid you'll have to put up with my English, but I am learning, estoy aprendiendo. I'm going to talk to you today about quite a famous project called the Mauritius pink pigeon recovery, Paloma. And this is a 40-year program now, which is amazing. When I put this together, I thought, wow, it's been 40 years already. And largely managed by the Durrell Wildlife Conservation Trust, a local group called the Mauritian Wildlife Foundation, and the National Parks and Conservation Service in the Mauritius government. My co-author on this presentation is Dr. Carl Jones, who has been very key to this project, and I'll talk about him in a minute. He would be here today, but he hasn't been well, so he sent me to talk about him. Can't speak Spanish. But I am representing a group called the Island Endemics Foundation today, and Juan Martinez will talk to you tomorrow a bit more about them. I was involved in the Pink Pigeon project since the late 1980s. I was actually in Mauritius for about 14 years, from 1987, and I led the Pigeon project from about 1989 through to the early 2000s. And I also completed a PhD on it, so I know quite a lot about pigeons. Subsequently, I've been continuing to work on island, endemic, and endangered species. I don't live in Mauritius anymore, but I'm currently based in the Caribbean, where I've been for the last 5 or 6 years working on very similar programs. So there are two key people in the story of the pink pigeon. This is Gerald Durrell. Many of you may know him. He has been integral. He started. Well, no, he didn't start. He has been integral in the recovery of the pink pigeon. He immortalized the pink pigeon and the golden bats, which were from the neighboring island of Rodrigues, in his 1977 publication, Golden Bats and Pink Pigeons, which told the story of his original expedition to Mauritius to rescue the critically endangered pink pigeon. And that was when the Jersey Zoo, which Gerald Durrell founded, when they began the captive breeding program for this species in 1977. And that's a photo of Gerald Durrell has now passed away. He died in 1995. That's a photograph of his wife, who is still very important to the Durrell Wildlife Conservation Trust as it is. And the Durrell Trust continues their support of the program. And that's also a picture of Mr. Durrell. Oh, I'm sorry. Okay, yeah, you don't get that feedback. Photograph of Gerald Durrell feeding pink pigeons on one of the very early releases in Mauritius. The other key person, as I mentioned before, is Professor Carl Jones. Carl began his work in Mauritius in 1979. Here he is holding a very small young baby pink pigeon, and he has been there ever since. He is the chief scientist for the Durrell Wildlife Conservation Trust. He is a founding member of the Mauritian Wildlife Foundation, which was formed to recover not just the pink pigeon, but the other larger land birds, and which has now grown into a whole island and offshore islands restoration program. He was recently awarded a very prestigious prize in Indianapolis, prize for his incredible work on Mauritius and saving these critically endangered species. And he, as I said, this is now included offshore island restoration, a lot of seabird work, and you can see him there, a recent photo with Dr. Vikash Tataya, who is currently Conservation Director, Mauritian Conservation Director for the Mauritian Wildlife Foundation. So just in case you're not sure where we are, this is Mauritius. It's within a group called Mascarene Island. Mauritius, Republic of Mauritius actually also includes the island of Rodrigues, also suffers a lot of extinctions of endemic species, and the French island of Réunion. The title of this talk, called The Mauritius Pink Pigeon, gave it a genus Nessoinas. And it's been going back and forth between the unique genus Nessoinas and just your regular columba. I think the current thinking, certainly what Professor Jones thinks, is actually the closest relative is probably a pigeon from Australia, and actually from a lineage from Australian and Pacific groups. And that wouldn't be unusual. We have other species in Mauritius, like bulbuls, ringlet parakeets, and some other fruit bats, which also come from that region. And you can see the real similarities. The white-headed pigeon, called Australian white-headed pigeon, is on your right there, and the pink pigeon is on the left. Very similar in its behavior, ecology, as well as phenotype and morphology. So what we know about the pink pigeon now, we didn't know this when we started, is that it is largely a woodland species. It's pretty sedentary in terms of it doesn't migrate. It's obviously endemic to Mauritius, and it much prefers canopy. It's a canopy feeder. Here you see on the left an adult bird, and on the right a young bird. And one of its classic features is a very, very bright rufous tail. And these are two of the youngsters, a newly hatched squab and about a 10, 12-day-old chick. So it really loves to be in the canopy, but it does also spend a lot of time on the ground. It has very low wing loading, so it has broad-rounded wings. It can fly up vertically, but it's not a strong flyer. One thing you notice when you handle it a lot is it really grips. It's got very strong feet, very strong tarsus, and it balances on the outer edges there, feeding on flowers and leaves and some fruits. But it'll also pick up fruits on the ground. Of course, partly its ground-dwelling habits has been part of its demise as well. So the history, or the decline of the pink pigeon, is really entwined with the loss of forest across Mauritius too. So you can see in these charts here, very nicely put together, the decline in native forest from the sort of early 1800s. And in the 1830s, about 65% of forest was still remaining on native, 65% of forest was still remaining on Mauritius. But that very rapidly disappeared with the freedom of slaves, who then moved into the forest, developed agriculture, and there's huge demand for land and for timber. By the 1930s, 1940s, only about 3 to 4% of Mauritius was under forest, and that actually continued through to the 1980s, when there was a large area of pink pigeon habitat. Here. There we go. A large area, this is all pink pigeon habitat, large area of pink pigeon habitat was put under pine plantations, actually by the World Bank, and that carried on through to the early 1980s. And you can see the parallel reduction in range of the pink pigeon. In the 1950s, it was already pretty rare, and in fact it was recorded as, just anecdotally, as rare in the early 1900s, so it's always been rare. And this is the sort of the shrinkage here of the native forest, until finally the last remaining population was actually in an exotic plantation of Japanese red cedar, Cryptomeria japonica. It's one of the last few birds in there. It was pretty much the only place where they could survive. They were a little bit protected from the cats cats and rats that didn't really like spiky cedar trees. So the wild population continued to decline into the late 80s, and by 1990 we only knew of 9 or 10 birds, and they were only existing in this tiny little cedar plantation. In addition to forest loss, the usual suspects, invasive species, both plants and animals, crab-eating macaques, small Indian mongoose, feral cats, pigs, deer, rats, the usual suite, all have been on Mauritius for quite a long time, or a few hundred years. In addition to these are all predators of pink pigeons, in addition to the predators, invasive plants also continued to degrade the native forest. And what you can see here is remnant native trees poking out of a sea of Chinese guava and privet. This is just a real synopsis of the timeline of the history of the project. Early studies were done prior to when Prof. Jones was there and when Josie got involved by a gentleman called Stanley Temple, who still works at the University of Wisconsin, and David McKelvey. Captive birds were brought in the late 70s, both into Mauritius and into Jersey Zoo in the Channel Islands in the UK. And there were some trial releases done in the 80s. We didn't really know a whole lot, so actually Carl Jones did an extensive review of the biology, trying to gather as much information as possible so we could learn about it. And then we started with the sort of hands-on management to actually recover the species. We started banding birds in the wild in that red cedar plantation. We started managing the predators, and we did intensive captive breeding and reintroduction program. And this is sort of in a graphical form from 1950 up to, this is already about 10 years old, but to be honest, the population hasn't increased at all here. It's really just hovered around 350 to 400 birds. This is the historical decline, and our projections, if you extrapolate that, suggests that without any hands-on management, the species would have gone extinct in the wild in 2002. These are major cyclones, which probably had a big impact, and these estimates are probably before and after the cyclones, just about here. And then this is where the intensive management started. These are birds that were brought into captivity. These are your founders. The ones in parentheses are actually the ones that bred, although more were brought in, but they didn't actually contribute to the population. And then this is a period of intensive releases, and you can see had an immediate effect on the population in the wild. There were only 11 founders brought into captivity. We did bring in a couple more later on, as you can see here, a few more later on, but this is the original core founder population. It's very likely that these birds are also related to these birds. So essentially, we only have 11 founders, and you can imagine the inbreeding effects of that. I'll talk about that in a minute. The captive population was primarily to maintain a safety population, both maintain the diversity, but also provide birds for reintroduction. So the population in Jersey Zoo was managed through international and national stud books to maintain genetic diversity, and that's really been important, which I'll talk about in a minute. The Mauritius population was really to provide birds for reintroduction. And one of the problems we had, really, was trying to use the international population to provide birds for reintroduction. We primarily introduced young birds, which seemed to be which was more successful. And if you're trying to bring birds from countries around the world to Mauritius, you can imagine the bureaucracy often, and that often delayed things. The birds weren't young when they arrived anymore. So by having a captive population in Mauritius, we could produce large numbers of birds, and it was very easy to just put them out into the wild. Really intensive period of release that really kick-started the project, kick-started population growth between 87 and 2000. More than 300 birds released within a very short space of time. In fact, more than 200 of those were released in just 3 years. We released them in different sites on mainland Mauritius, and one offshore island. I'll show you that in a minute. We had a very good survival rate. We just tracked it to basically 30 days. We reckon that by 30 days out in the wild, the birds were self-sustainable, or self-sufficient. They could survive. And they were held in situ at the release site for a minimum of 30 days. Small groups worked best, and younger birds worked best. Use soft release techniques, so the birds would come up to aviaries. This is quite an old one, we've got several others now. Come up to the aviaries and be there for a month. They basically get used to the surroundings. You can see here, these are little release hatches, and we could keep an eye on the birds while they were acclimatizing. The soft release method essentially meant we could recapture them whenever we needed to. Sometimes birds got a bit skittish, or they didn't do very well, they didn't feed very well, so we could catch them up, feed them up, give them a health check, and let them go again. And this soft release method worked very, very well. What we did find was over time, once you establish a population in one site, you didn't have to keep them in the aviaries for so long. The biggest challenge was actually establishing the first population, the first few birds. After that, when you started releasing other birds into that group, it got easier and easier. The birds were less likely to disperse too far. These are the different release sites. This is the intensive period in the mid-90s released at these three sites here. This is upland forest. This green area is the current sort of distribution of native forest, and is currently the Black River Gorges National Park. So we were trying to basically repopulate their historical range where they were sort of last. Up here, this is all populated and sugarcane and everything else now, so this is really a core area in the southwest that's remaining. We released them on an offshore island, which is low and dry forest, and now currently there are additional translocations, sort of filling in some of the gaps here. These are two newer translocations, not captured bred birds, but translocations of birds that come from other populations. And those are in 2008, 2009, and this one is actually due, this population is due to be released in a few months. And there's a range of mountains here on the east coast. It's not very good native forest, but it already supports a good population of precious kestrels, so we have some hopes there. And these birds actually do now move between each subpopulation, as you can imagine. So there is mixing. It's not extensive, but there is mixing. This is an example of the first release site up in what we call Breeze Fair. This is sort of a plateau, high, 700 meters elevation, evergreen forest. And then also experimenting releasing them into dry forest on an offshore island that had been cleared of invasive predators. This is about 25 hectares, this island, and it's managed as a nature reserve by the Mission Wildlife Foundation. We had to manage for some of the reasons they originally declined, which was food shortages, a very degraded forest, seasonal shortages. There's a dry season when there's often not enough food available for them, and so we would supplementary feed them. And this is a technique that's worked extremely well. There's a lot of research been done on it, both in Mauritius and in other countries like New Zealand, where they've been supplementally feeding endangered parrots and passerines. And this ongoing. We also had to manage the predators. We couldn't eradicate entirely, but we could control cats, mongooses, and to a lesser extent the cats. The recovery project also galvanized the creation of a national park. The national park wasn't there when Prof. Jones started. It was created in the mid-1990s. Black River Gorges, which is the primary area of the southwest here where most of the remaining forest birds survived. There's subsequently been a lot of habitat management, weeding out all the invasive plants, restoring with native trees, like shown in the last presentation, and also fencing, trying to keep out our native deer and pigs, which both graze the areas and will cause an awful lot of soil erosion and tree root damage. These areas, there's about, they call these conservation management areas. They're mostly small in size, 10 to 30 hectares, but there are about 8 or 10 of them at the moment, and they're hotspots for birds and for endangered plants as well. One of the through all the program, we have maintained an intensive research program, monitoring and research, to the point at which almost every bird is known. And some of the results have been some interesting, some surprising. So one thing we noticed was this quite significant difference between the population dynamics between the different subpopulations. These are all on the mainland of Mauritius, and this is the little offshore island. This is the wild population, and then it was the last remaining wild population, which we also managed, and then these were reintroduced populations on the mainland. And you can see that they're all behaving slightly differently. These are the releases initially, at these initial release periods, and then after which they're basically doing their own thing. And you can see there's in some places incredible crashes, in others just pushing along going up, and some of them just, slow decline. So they're all behaving quite independently, and understanding that is the real challenge. In addition to these differences between populations, we've also got differences, a lot of variation within populations. This is an example from the offshore island, Îles Aigrettes. This is survival of adults over time. And as you can see, they're going through these cycles. And then this is recruitment of youngsters, and ultimately the recruitment on the island here has started to decline quite significantly, such that we are currently at the stage of trying to figure out, okay, how do we restore this sort of population, how do we inject a bit of life into it. But understanding these cycles, these ups and downs of what drives recruitment and what drives survival and mortality is one of the challenges that we currently are working on. Another challenge has been, of course, effects of inbreeding. With only 11 founders in the captive population, and with the population having been rare for nearly 100 years, inbreeding is an obvious sort of concern. However, while we have found some impacts on survival, these are very highly inbred. These are some of the adults in the wild. While it does seem as if very highly inbred birds do have a poorer survival, some of the intermediate inbreeding coefficients and those that aren't really inbred, it's a little less clear. And part of this reason might be because really there are no non-inbred birds. There were only 11 founders, the population went down to 9 to 10. There's a very good chance that many of them were closely related. So this may actually just be one sort of population from a genetic perspective. This is based on pedigree analysis. But there are some other effects on hatchability, fertility. Pink pigeons have very, very poor egg fertility. One of the main challenges that we're dealing with today is avian diseases. And this is really the impact of disease on the populations and the significance of disease in the species' original decline only really became apparent once we got a lot of birds and we had a population that we could actually study. And also because disease very often is related to population size. The more birds you have, the more likely you've got transmission rates. And if you only have 20 birds, if 5 die, is that significant, or is it 5 birds dying out of 200 birds? So you really need populations in order to understand the real impacts of disease. Trichomoniasis is a protozoan parasite, Trichomonas, very common. It's a very typical pigeon disease, and it is affecting endangered pigeons in different parts of the world also. I know it's a problem in Galapagos and in the European turtle dove. In the UK, currently there's a particularly virulent strain of Trichomonas circulating. It causes these massive lesions. This is a young bird. It typically affects young birds. But there was a very intensive study completed in 2002 to 2004, where she screened over 400 birds every 2 months for nearly 2 years. And this is not just wet mount screening, it's protozoan parasite, but we used a culture swab, so you could actually detect infection with parasite even if it wasn't showing clinical signs. And so nearly 90% of the population that was swabbed tested positive at least once over those 2 years. But the actual clinical signs, i.e. smaller signs of these, the lesions, was only in less than 2% of the population. So many birds were infected, many birds could live with it. Some birds are much more susceptible than others. It invades the tissues and it does cause mortality, particularly in swabs and young birds. So in on the yellows of red population in the lowlands, it would cause about 60% of swab mortality. And you can see here, this obviously, where you have persistent infections, where birds are persistently testing positive, there does seem to be an effect on its survival compared to those that are never infected. And again, understanding this is why do you have these different responses, is one of the research focuses that we have currently. So this is related to this. One of the new lines of research has been on genetic paucity, genetic diversity, and whether we can improve the genetic diversity of the wild population, the wild amphibian population. And there have been two lines of studies going on. The Early Institute here in the UK has actually mapped the genome of over 250 odd pig pigeons and has found that the alleles for immunity are deficient in many of the birds. And they have aligned that deficiency with susceptibility to trichomoniasis. So the birds that were more susceptible to trichomoniasis are found to be poorer in their immunity alleles. And this is really, really recent. They've only just been looking at this in the last few months. The second line of genetic management is whether we can identify unique alleles in the captive population. So while all the released birds came from captive bred, originally captive bred birds in the captive population, we're not 100% sure whether we captured all of the heterozygosity. And so what's apparent is that over time, the allelic richness and the heterozygosity has been declining. And a young girl out of Durham Institute of Conservation Ecology at University in the UK modelled what it would look like. She identified some unique alleles in the captive population, and this is in Europe or in England. And she modelled what benefits there would be for the wild population by breeding from those birds and injecting them into the wild population. And there would be some benefits. Generally, it would raise, we got heterozygosity, pretty much she looked at the whole population and in some of the subpopulations. Some of the subpopulations, it would increase heterozygosity by about 26%. So that's just at the modelling stage right now, but the focus is to breed up some of those birds in the captive population and continue more releases in order to improve the genetic diversity of the wild population. The other big challenge we're facing right now is how to manage the population exhaustive. It's supplemental feeding, predator control, managing habitat. Very labor intensive. How do you take that to scale and make it cost efficient and sustainable for the long term? And so this is where some of the technology comes in. I don't know if you've come across these. They're good nature traps in New Zealand. They're automatic. They don't require manual labor. They will set and reset 20 or 30 times before anybody has to go and check them. Very efficient, a little bit expensive, but proving their worth in many different countries now for rat control and mongooses. Supplemental feeding, looking at more sort of automated type hoppers. This is grain, this is on a release pedal to stop other birds getting into the grain, which is of course where disease transmission occurs. And then landscape level management of habitat. Currently, the British government is looking at scaling up the conservation management areas, which currently, like I said, are in set 25 up to 50 hectares, scaling it up to 150, 200 hectares, and creating what's globally known as mainland islands. And this is a concept that was developed in New Zealand. Some of them use fences, keeps out all the predators. Some of them is really just a very high intensity core area that basically provide a source of birds that could repopulate other parts of the protected area of the national park. So it's just understanding how to manage all that, the species in the long term. So after 40 years, what are the sort of most critical things to take away? The intensive care and the hands-on management was critical. The species would have gone extinct without that approach. Having an experimental strategy by releasing birds in different places, different habitats, seeing how they responded, understanding what the issues were, that has really helped us to understand the birds' needs. Having high-quality research. The program has teamed up with many different academic institutions all over the world. And they have been able to really focus and drill down into these questions of population dynamics and inbreeding effects and avian diseases. And that continues. And I think also having to plan for the long term. There's no quick fixes to these. This was started in the late 70s and is continuing today. The current population of the pink pigeon has been hovering around 400 birds for the last 10, 15 years. And we don't really know why that is. There are density-dependent effects. It may be that management needs to be improved, standards of management. But those are things that we have to learn, we have to research and understand in order to increase the birds, increase the population there. 400 is not enough for long-term sustainability. But I think for me, and we say this often, in an era that is moving away from single species focus and moving towards habitat restoration and landscape level sort of practices, really the recovery of the pink pigeon along with the Mauritius kestrel and parakeet, focusing on those species has really generated whole ecosystem restoration and protected area creation and management. Without that beginning, we wouldn't be where we are today. So I'm all for species conservation and what it can do. But people can focus more on, especially something like that. So one of my personal goals now for the future is actually using a lot of what we've learned in Mauritius and applying it to other pigeons. So Juan is going to talk to you about this corridor. I'm working with a group in Grenada in the Caribbean on the Grenada dove, 150 birds remaining, to try and see if we can apply some of the techniques that we've learned to recovering that species too. Have an endangered Patagines Puerto Rican plain pigeon. If anybody would like to come and have a go at that one, it's critically endangered. and we know very little about it, and I would love to have somebody look at that species. It's a bit more like the oral pigeon. It's probably a stronger flyer, a little bit more sort of migratory across Puerto Rico. And then of course the ultimate little dodo, which is Didunculus, the tooth-billed pigeon from Samoa. I was out on an expedition looking for that a few years ago. There's a few folks now trying to decide how on earth we can recover that species. Very enigmatic and very elusive. Mauritius has generated a huge team. This is just more recently, Mr. Prof. Jones. Durrell set up a training academy in Mauritius, which trains both Mauritians and also fee-paying, budding endangered species biologists. And they want to take this program to scale as well and develop similar training programs in other parts of the world, such as the Caribbean and Madagascar, where they have a big program. So I'm interested in matchmaking endangered species recovery projects, matchmaking people with people across the world to try and exchange ideas and information. Yeah, sorry. Okay. Exchange of ideas and information. So if you're interested, let me know. Okay.